Hello everyone, today I am here to give project presentation on self-balanced switched capacitor based 9-level inverter with reduced switches under the guidance of Ganesh sir. Contains objective, introduction, existing method, proposed method, result analysis, advantages, applications, conclusion, references. Objective: to develop self-balanced switched capacitor based 9-level inverter with reduced switch. Introduction. Multi-level inverters have been gained popularity in renewable energy conversion systems and industrial applications due to its high-quality output waveform. The attractive feature of multi-level inverters are near sinusoidal output waveform, low dV by dt stresses, reduced power loss, and total harmonic distortion. The traditional multi-level inverters are neutral point clamped multi-level inverters, flying capacitor multi-level inverters, cascaded H-bridge multi-level inverters. Existing method: neutral point clamped multi-level inverter. Disadvantages: that the maximum voltage which we can get from it cannot be more than half of input voltage. This problem can be solved by increasing the number of capacitors, switches and diodes. Number of clamping diodes increases with the increase of each level. DC level will discharge when control and monitoring are not precise. Flying capacitor multi-level inverters. Disadvantages: due to the high frequency switching losses will takes place. Voltage control is difficult for all capacitors. Poor switching efficiency. Capacitors are expensive than diodes. Cascade H-bridge multi-level inverters. Disadvantage: every H-bridge needs a separate DC source. Due to large number of sources, applications are limited. Proposed method. The proposed multi-level inverters uses a low voltage DC input source to charge the capacitors multiple times of the input source amplitude. The creation of bipolar output voltage without requiring a high voltage full bridge inverter to perform in medium high power applications with low input voltage sources. It is not required a closed loop controlling method or additional circuit balancer for balancing capacitors voltage. The number of switches capacitors is lower in the proposed circuit. Circuit topology and capacitor charging path. It consists of two half-bridge inverters. It is capable of charging the capacitors located in the switched capacitor cells more than the input voltage amplitude. The voltage produced by switched capacitor cells are transferred to the load terminals through lateral half-bridge. Each switched capacitor cells includes 4 capacitors, 6 power switches and 2 power diodes. Capacitor charging path. In figure A, it can be seen that when switch S3 is on, capacitor C1 and C2 begin to charge through diode D1. In figure B, it is evident that when the switch S2 is on, capacitor C3 and C4 begin to charge through diode 2. When one of the bidirectional switches S1 and S4 are conducting, the capacitor in the middle, that is C2, C3 charges as shown in figure. Switching logic. VDC refers to the input voltage. The proposed converter utilizes redundant switching modes to generate voltage levels. The input voltage is 2 volts in this mode. Mode S2, S4, S7 switches are turned on, whereas the C3, C4 are started charging. Result analysis. In figure displays the output voltage and current under RL load. Since it is a purely resistive load, the voltage and current waveform should be in phase with each other. This means they rise and fall together. The voltage and current should stabilize to consistent values over time. In figure displays the output voltage and current under R load. The voltage waveform will show how the voltage across the load varies with time, when the current waveform will show the corresponding current flowing through the load. Phase relationship. In a RL circuit, the current waveform may lag behind the voltage waveform due to the inductive component. Load voltage and current for dynamic load condition. Load with R equal to 300 ohms. Since the load is purely resistive, the voltage and current will be in phase with each other. Load with RL equal to 300 ohms plus 350 millihenry. Here the load consisting of both resistance and inductance. This creates a more complex behavior due to the presence of inductance. When the inductive load is introduced, the current waveform might lag behind the voltage. Load voltage under current for variable modulation index. Modulation index equal to 0.4 from t equal to 0.3 seconds to 0.4 seconds. Modulation index where the amplitude of the carrier signal dominates with slight variations corresponding to the modulating signal. The voltage and current waveforms will flow the modulation pattern with the current waveform begin modulated by the voltage waveform. The figure shows the output voltage and current waveforms with a pure resistive load are shown in figure. It is clear that the recombinant converter can increase the source voltage magnitude from 24 volts to 48 volts. Load voltage and current for variable frequency 50 Hz from t equal to 0.4 seconds to 0.5 seconds and frequency equal to 100 Hz from t equal to 0.5 seconds to 0.6 seconds. The output voltage and current waveform with inductive resistive loads are shown in figure. It is clear that the recommended converter can increase the source voltage amplitude from 24 volts to 48 volts. FFT analysis, load voltage THT. The harmonic spectrum of the load voltage together with the corresponding total harmonic